All right, everyone, welcome back again. We are now into section 17.10, and that's looking at organs that have secondary endocrine functions. And so a lot of this is a little bit more than I'm really going to ask you to know, but it'll be interesting to walk through nonetheless. So the first I'll start with is the heart. And it says when the body experiences an increase in blood volume or pressure, you'll get the cells of the heart's atrial wall to stretch. And in response to that, they'll produce and secrete the peptide hormone atrial natriuretic peptide, or ANP. And ANP signals the kidneys to reduce sodium reabsorption, which decreases the amount of water that's reabsorbed from the urine filtrate, and it reduces blood volume. Okay, so it does other things too, which include the inhibition of renin, which we're actually going to learn about in a few sections down, which will inhibit the renin angiotensin aldosterone system, or RAAS, or RAS, and vasodilation. So therefore, ANP can both decrease blood pressure, decrease blood volume, and decrease blood sodium levels. Okay, let's move on to the gastrointestinal tract, or the GI tract. The endocrine cells of the GI tract are located in the mucosa of the stomach and small intestines. Some of those hormones are going to be secreted in response to eating a meal, like aid in digestion. One example is gastrin, which is a peptide hormone that's secreted in response to stomach distension, which basically just means your stomach is getting full, and it stimulates the release of HCl, or hydrochloric acid, which is an extremely acidic material that will start breaking down whatever's in your stomach. The other one is secretin, which is a peptide hormone that's secreted by the small intestine as acidic chyme, which is basically just partially digested food and fluid, and that moves from the stomach, and it stimulates the release of bicarb, or basically bicarbonate, from the pancreas, which buffers that acidic chyme, inhibits basically the further secretion of hydrochloric acid. Basically, adding a buffer basically makes it more neutral, and so that eventually when it leaves your GI tract, it doesn't burn the rest of your body. Anyway, that's all I'm going to talk about. It's pretty cool there. The next are the kidneys. When the kidneys will get a decline in blood flow, that will stimulate them to release the enzyme renin, which is what we talked about a little bit earlier, which triggers the renin angiotensin aldosterone system, or RAS system, and it stimulates the reabsorption of sodium and water. And that will increase blood flow and blood pressure. So it's a little bit different than what we talked about with what the heart did, which inhibits that RAS system to decrease blood pressure. This increases blood flow and blood pressure. The kidneys also will play a role in regulating blood calcium levels through the production of calcitrol from vitamin D3, which gets released in response to secretion of PTH, or parathyroid hormone. The kidneys will also produce erythropoietin, basically EPO, and that gets released in response to low oxygen levels. And what that does is it stimulates production of red blood cells, or erythrocytes, in the bone marrow, and that increases oxygen delivery to tissues. Remember, red blood cells are the blood cells in blood that carry oxygen to the rest of your body. You might have heard of EPO as a performance-enhancing drug that a lot of times cyclists will use. Okay, the skeleton has two that we'll talk about. Normally, scientists and physicians used to think of bone as just target sites for hormones, but recently we have found that researchers have found that the skeleton also produces at least two of its own hormones. The first is fibroblast growth factor 23, or FGF23, and that's produced by bone cells in response to increased levels of vitamin D3, or phosphate, and that triggers the kidneys to inhibit the formation of calcitrol from vitamin D3 and to increase phosphorus excretion. And the other one is osteocalcin, which is produced by the osteoblast, and it stimulates the pancreatic beta cells to produce insulin production. It also acts on peripheral tissues to increase their sensitivity to insulin and their utilization of glucose. Okay, next is the adipose tissue, or the fat tissue. It produces and secretes several hormones that are involved in lipid metabolism and storage, which, no surprise, that's what it does. One important example is leptin, which is a protein that's manufactured by your adipose cells, and it circulates in amounts that are directly proportional to the level of body fat. So leptin is released in response to food consumption, and it acts by binding to brain neurons that are involved in energy intake and expenditure. And they think that the binding of leptin also produces that feeling of being satiated after a meal, and it'll reduce your appetite. I think that's all I'm going to talk about here. Let's talk about I'm going to skip the skin here. Let's go to thymus. Thymus is an organ of the immune system that's actually larger and more active during your infancy and early childhood, and it actually begins to atrophy as we age. And its function is in the production of a group of hormones called thymosins that contribute to the development and differentiation of your T lymphocytes, which are immune cells. And we're not really sure what thymosins do yet, but it's clear that they contribute to the immune response in some way. And lastly is the liver. Um, the liver is responsible for secreting at least 4 important hormones or hormone precursors: insulin-like growth factor, or somatomedin, angiotensinogen, thrombopoietin, and hepcidin. When that insulin-like growth factor it's the immediate stimulus for growth in the body, especially the bones. Angiotensinogen is a precursor for angiotensin, which increases blood pressure. Thrombopoietin stimulates the production of blood platelets, and hepcidins block the release of iron from cells in the body, which helps regulate homeostasis and just the levels of iron in our body fluids in general. Here are the major organs and their hormones listed in a chart form. Basically, all that we skipped in the skin section was cholecalciferol, which basically is modified to form vitamin D. And of course, vitamin D is extremely important to have in the body for a number of reasons, including bone density. And so with that, I'm going to end that there. We got one more video to go through in this chapter. I'll see you in that one.